Hello, multivariable calculus students. This is section 9.4 on the cross product, and this video is on examples 7 and 8. So in example 7, we're going to find a vector perpendicular to the plane that passes through the 3 points P, Q, and R. This will be a very common problem for us to figure out and to use is a vector that's perpendicular to a plane. So if you envision a plane in space, there are many vectors that are going to be perpendicular to the plane. We're going to utilize 3 points that are in the plane. So in other words, if you had, if you could sort of just envision some plane like this, and you have 3 points in the plane, let's say we have P and Q and R like that. All those points are in the plane. Our goal is to find a vector that is perpendicular to the plane. So if we're able to create a vector PQ and another vector PR, both vectors PQ and PR, both of those vectors are in the plane. They're parallel to the plane. If we were to take the cross product of those two vectors, then we get a vector that is perpendicular to both of them, and so then would be perpendicular to the plane. So we're first going to calculate PQ, and we did this way back in the first couple sections of this chapter. You take, just as a quick review, you take the first component of Q, which is -2, and you subtract the first component of P, so we get -3. Then we take the next component, 5, and subtract 4 and get 1. And then we have -1 minus 6, so we have -7. And then we're going to do the same thing for P, for the vector PR. It's really important that you have the same initial point. So I went PQ, and now I'm going to go PR. If you decided you wanted to do a vector QR, then you need to do the next one QP. Your answer would be correct if you did the mathematics correctly, but it might look different than the one that I get, but it still would be perpendicular because again, envision a plane. You could have a huge number of perpendicular vectors associated with that particular plane. Okay, so we're going to do PR. So we get 0, -5, and -5. All right, we're going to take the cross product between these two. So we have the vector PQ crossed with PR. Could you do PR crossed with PQ? Of course, you'll get the negative version of what I'm about to get. Okay, we have I, J, and K. And the first vector, -3, 1, and -7. Second vector, 0, -5, and -5. And then we'll perform the cross product. Now we've done a couple of these, not too many yet. So I'm going to kind of take it slow here just because it's still pretty new. So we have I multiplied by 1 times -5. So -5 minus +35. So we get negative, I'm actually going to write it out. We get -5 minus 35 minus J. And then we have for J, -3 times -5 minus -7 times 0. So we have 15 minus 0. And then for K, we have -3 times -5 again. So 15 minus 0. So our vector is, I'm just going to write it in this format, is going to be -40, -15, and 15. Now this is certainly an answer. That vector is perpendicular to this plane. Let's say that you wanted to scale this for some reason, and you decided you'd divide by, I don't know, 5. So you get the vector -8, -3, and 3. That's totally fine. That vector is also perpendicular to the plane. What if you multiply by -1 and you got 8 and 3 and -3? Totally fine. Let's say you wanted to scale it by 30. Fine. There's a bunch of vectors that are perpendicular to this plane. That's what we're trying to find. Okay, let's go ahead and take a look at number 8. So number 8 is utilizing the exact same 3 points, P, Q, and R, but we're going to find the area of the triangle in between P, Q, and R. So I'm going to draw this out again real quick. So let's say you have P here and Q here, and then we have R, let's say there. Actually, let me do it this way. Okay, let's connect these with our vectors. So we have PQ, we already made that vector. We have PR, we have that vector. Let's go ahead and create our parallelogram. Okay, now the cross product between PQ and PR was -40, -15, and 15. It's really important that we do not scale this because we are no longer looking for some random vector that's perpendicular to the plane. We're looking specifically at the exact triangle that is formed by P, Q, and R. So if you scale this, you've now scaled the triangle and now you've scaled the area. So you'll get an incorrect answer. The only reason we could scale example 7 is because we didn't care the size of the vector, we just cared that it was perpendicular. So we could scale it all we wanted. Okay, so in this case, what we're going to do is take the magnitude of PQ crossed with PR, and I'm just going to use a calculator on this, but just as a quick review, we got -40 squared plus -15, oops, sorry, -15 squared and 15 squared. But again, I'm not going to expect anybody to do that in their head. So this is the square root of 2050. That can actually be reduced a little bit to 5 root 82. Okay, now what is that? Well, that is going to be the area of the parallelogram. Okay, so what we want is the area of the triangle right here. So just kind of deductively, I think you could probably figure it out. All we're going to do is divide that area by 2. So we have 5/2 root 82 is our answer. That is the area of the triangle. All right, and that's example 8. The next video will cover the remaining examples for this section.